In this video, we are going to be graphing a polar equation. We are graphing a 3 times cosine 3 theta. That 3 theta is going to mess with something a little bit. It's going to be a little bit different than what we did on this previous problem. This one just kind of created a circle. If you remember back, this changes your period of how often your graph kind of cycles through. So the period was always 2 pi, but then it was being divided by that b value. So that's our period. I don't want to do all these values to plot a whole bunch of points. So I'm going to go back to kind of how we graphed um, a cosine graph was we focused on kind of the main 5 points where your cosine graph would have started at a high point when it went to the middle, then low, then middle, then high. Normally we would have been a 2p here or a 2 pi here, but this is our period. So let me do a little bit of work as if I'm graphing this. I'm going to ignore the 3 for a second, but I'm graphing this. And so my period would be 2 pi over 3. And if I cut it in half, that would be pi over 3. And then if I cut it in half, I'm going by sixths. So 1/6, 2/6, 3/6, which is pi over 2. And then our cosine graph would look like this. Right, so that's our graph. All right, so we're going to pull these values, and this is a 1 and a -1. We're going to pull these values. Those are the points we're going to actually throw into our table so I don't get all these fractions and decimals and everything. We're going to plot the nice points and kind of see if we can figure this out. So we're going to start with pi over 6. Right, so if we plug in pi over 6, we have to multiply it by 3. So if you do 3 times pi over 6, you're really graphing 3 pi over 6, which is, not coincidentally, a nice value. So if you do cosine of pi over 2, it's actually this point right here. So we can convert every single one of these, but shortcut is we actually have all these values. So this pi over 6 is 0. We're going to do pi over 3, and that's going to give us a -1, right? So I guess we should probably start with a 0. Let's do that. 0, pi over 6, pi over 3, pi over 2, and a 2 pi over 3. So the long is we can take all these values, multiply it by 3. It's going to turn into these nice points, but we've already done that actually by shifting your period around and kind of redoing our graph. So we can ignore all of that, and we can just pull values. So if we do cosine of 0, it's going to give us a 1. So it's going to be 3 times 1. And then here it's going to be 3 times pi over 6 is 0 because it's really like us graphing 3 times pi over 6, which is pi over 2. And pi over 2 is 0. So 3 times 0. And then here it's pi over 3, which we've already adjusted the period, would give us a -1. So we're looking at distance of 3, distance of 0, distance of -3, because this would be like us plugging a 3 times 3. It would be like graphing cosine of pi. And then here, this would be like graphing cosine of 3 pi over 2. But again, we've already shifted it, so that's a 0. And then 2 pi over 3 would be back to the beginning. So that would be a 3 times 1. If you wanted to throw it into this, you would be doing 2 pi over 3 times 3, which is really 2 pi. You can kind of see that you've gone through your whole cycle of nice values, which would also be like pulling points from your unit circle, right? You'd be hitting all the axis. So you'd be hitting an x-axis, a y-axis. So you can look at all of that way too. All right, so let's see what this thing looks like though. So when we're at 0, we're at a distance of 3. So at 0, we're actually at a distance of 1, 2, 3. So 0 radians. When we're at pi over 6, which is 30 degrees, we're at a distance of 0. So this graph actually pulls in. And then when we go to pi over 3, we go to a distance of -3. So pi over 3 should be here, but it got reflected to here. So this graph goes from here to there. And then at pi over 2, which is 90, we should be back at a distance of 0. So it gets pulled back in. And then at 2 pi over 3, which would be right here, we're back at a distance of 3, not reflected or anything like that. So then that distance looks like that. So far we've gone kind of like this. So let's continue. So if we went to the next one, this would be 5 pi over 6. But the reality is that this 5 pi over 6 would be us just continuing this pattern. So 5 pi over 6 would be the same as pi over 6. So we would just kind of be right back to a height of 0. So we would be 3 times 0. So at 5 pi over 6, we would pull it back to 0. Right? And then we would go pi. So if we did pi, that would continue on to our pattern, which really, if you start to look at, this was the period. So we go 3, 0, -3, 0, 3. So we're at, sorry, extended that a little too far. 3, 0, and then we'd be at -3, and then 0, 3, starting our pattern all over again. Okay, so let's put all these pieces together. So that's 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, on and on and on and on. So 2 pi over 3, so we got pi over 2. We pulled ourselves back to 0. 2 pi over 3, we were at a distance, so we went from here to here to here. And so if you go now at pi, you're back, should be at 3, but it reflected, and you look like that. And then after that, it's just going to be this whole pattern all over again. So you get these petals, is what they're called. So let's validate, make sure that looks like it's supposed to look. So if we go into this y equals, I've changed my mode into polar. I'll go into my y equals, and I'm just going to graph 3 cosine 3 theta. All right, and then my window, I'm going to make sure that I'm in radians, and my window is my degree measurements, my angle measurements are 0 to 2 pi for one full circle. You should get away with the 2 pi over 3, but I just basically the calculator is going to repeat itself, so it's going to graph itself on top of itself. Just leave it from 0 to 2 pi is always a safer play. Decimal points, I don't know, the smaller this is, the more points it's going to plot, more accurate it's going to look. But if you do really small, it's going to take a real long time to graph it. So I'm just going to do a tenth. I went -6 to +6 on my x's, so the horizontal, and then my y's, I went from -4 to +4. And I can't go inside of 3, otherwise my graph won't show up. But I did go wider than up and down because this graph is wider than it is tall, just to kind of give it a little bit of a more realistic look. And so here's, right, so it started and it went out, it came down, and then it just kind of followed that pattern, and you kind of saw it kind of retrace itself because it did a second cycle because I went from 0 to 2 pi rather than just 0 to 2 pi over 3. So if I change my window to 2 pi over 3, I would like perfectly, no, we needed to go a little bit further. So that's why I mean, it's just safer to go 2 pi. And then there you go. So it graphs itself all the way around. So that is graphing a polar equation, a little bit more complicated because your petal is happening. You have these petals, you have this period being adjusted, and you kind of figure out what are my main points. Well, figure out what your period is, graph it as if you were graphing this kind of a graph, and then cut it in half, and that could be your scale. And then you can plot your points relatively quickly that way.